Hello, this is David Amos Brown, and this video covers AOS service providers and service clients. In this video, we begin to look at the topic of information usage from a more analytical perspective. To be able to create software programs, we need the ability to create pieces of information regardless of construction or type to support our program, the ability to create expressions for pieces of information in our program so the computer can evaluate new information on demand, and the ability to sequence the expressions in our program to control when and how our expressions evaluate so that we can produce answers that require many active pieces of information. If all the data we need in our program is inside our program, then this is all you need to calculate anything you can think of. But that isn't the real world. Just as often as not, we need data from sources outside of our program, like our database, for instance. This is where the client-service model of communication comes in. It models how two intelligent things like programs share information across boundaries. A service simply looks like a two-sided form. The client gets the form from the service, fills in one side, then sends the form to the service where the other side is filled in. Then the form is sent back. The service's assembly serves as the two-sided form. So at any given moment, all the information available in the universe for our program falls into two categories. Information that is readily available, no obstacle to access. In AOS, we use one of the addressable controls to go get local data for our programs. Information that is not readily available has to be requested from another source if one exists. In AOS, we use services and clients to cross program boundaries. Once we have the information we need, we create answers through calculation and the application of logic. Information clients usually initiate a communication event with a service and come to do one of only three possible things. Client comes to report information, client comes to get information, client comes to do both. But AOS adds one more for broadcast-type services like a conference chat. Service broadcasts to all recent clients when new information is available. Client input is seen by all recent clients. Recent clients can be cleared programmatically. This is a conference chat with one moderator. Okay, so let's see what that looks like in AOS. We're going to add a service and service client and set them up to work together. To be able to work with a service, the client has to know how to specify what to report or what it needs. This information is provided by the service in the form of a pre-designed set of service requests that the client retrieves manually in the design process. We're going to look at a finished example just like a cooking show. Here we'll show that the client input shows up on the service side when the service is requested. The discussion on the service side updates. The service can respond, and the discussion on the service and client side update. The service can respond anytime it wants, and the discussion updates on both service and client, and back and forth. Then we'll make one of these from scratch and see just what's entailed in this very simple and useful service. When we look in the service, we see that we have one recipient currently and can clear that. There's no recipients. If the service does input something new, the discussion as programmed will still update as shown, but there's no one to send back to. However, if a client comes back and says something more, then as programmed, both sides will update and the client will see that new input. Let's make one of these. We press F7 to add a control. The first control we need is a user data assembly. We'll call it our conference chat service example. In that assembly, we need two assemblies, a client side and a service side. We want the service side to be next to the client, so we put it in line. On the client side, we need a place for input for the client, a text box, and we need to see the running discussion for the service. We also need a service client. On the service side, we need the same kinds of things. We need a place for the service input. We need a place for the running discussion. And we need a service control to design. We move those to the top. We're going to do a little bit of display setup. We need more room than that. So we set up the discussion to be 300 by 400. Arbitrary choice, but that's a fair amount of area to see the discussion. We set the client input to also be 300 wide, but auto size height, depending on what we input. Save those settings. On the server side, we're going to do the same things for display. Set up the discussion to be 300 by 400. Set up the service input to also be 300 like the client side. Refresh the display. We want the client and service to stay open. So we do that here. Because this text just continues to add to itself, we want to set up the text box so that it scrolls to the bottom automatically. We use the mask for that. We do the same thing on the discussion side. Okay, so we have no services at this point, so we add one. In that service, we only need one input. We need what the client just said, latest input. When that happens, we want to update the discussion with that new input. So we express the discussion on the service side. And the discussion will update in two conditions: when the service input updates or when the client comes for the service. So there's the client trigger. We need the trigger for the service side, service input. And we're going to update the discussion. So the first thing that we want to do is add a couple of carriage returns to separate inputs. We use a text add function. We're going to set up the text add function. The first part is the current value of the discussion. The second part is the two carriage returns to separate the inputs. Then, because I have two different inputs and have to choose which one, we need a decision function. So we're going to add a text-based decision function. We need an output for our decision function. We'll call it discussion text output. We need a test value to find which branch to use. That test value will be the current trigger, and the current trigger will tell us which input just came in. We're going to have one branch for each trigger, and we will go get each of those triggers easily by selecting them from the triggers list. There we have our two branch test values. Then in each branch, the first thing we need to do is we need to add the correct prompt so we know who spoke, and then we need to add the correct input. Because both branches do the same thing, we'll copy and paste the two functions over to the service branch and then set up the client branch. This add text first part will be the result of adding carriage returns. The second part will be the prompt that we need. It tells us who spoke. Then we'll add the input that just came in. Which is in the service. Chat service request input result. That's the new client input. Then we hook up the branch result value, which is the last thing we did. Then we do the same thing to the service side. First part of the add prompt is add carriage returns. Then we add our prompt. Then to that, we add the new service input. And hook up the branch final answer to the last thing we did. That branch is finished. That decision function is done. Our expression result is the last thing we did, which is add the correct prompt and input. And we're done with the expression for discussion. When discussion updates, we want to then fill in the services assembly with a return value. It will trigger off of the discussion updating. It will go get the discussion, the latest value of the discussion. Then, in order to do a conference chat, we need a return trigger, so we trigger off of the last thing we did, which was update the service request return. And now the service is designed. We then save it. And the service is now ready and available for clients to use. To use a service, a client selects one from the Data Explorer. Once the service has been selected, the client now has the service finished design assembly, as can be seen here, where the client input is now available. The programmer on the client side then modifies the service requests to be filled in programmatically. To program the client, we set it up so that whenever there's new client input, the service client request input updates. When that happens, the client input addressable value will go get its needed information. We tell the data address where that information is, and it's in the client input text box. We then express the discussion text box to update when the services assembly returns. When the services assembly returns, the client start button will be pressed. We then go get what's in the service request return and put it in the discussion text box. Finally, we tell the service client when to go get service, and that is when the chat service request input updates. And the client is programmed. Let's see if it works. We input something on the client side. It shows up on the service side and then back at the client side. The service can respond, and it shows up on both sides, and the service can respond whenever it wishes. And it will show up on all clients that are currently connected. And that's an example of a service and client. Let's see what our programs look like in the Program Explorer. The Program Explorer shows us all the expression sequences in our application, which in this case is the root computer manager. Here we see 5 programs. The first program belongs to the computer manager and is a response to a library selection in the network settings. The second program starts when a client request comes in and ends with the service sending back. The third program starts with the service input changing and ends with the service sending back. The fourth program starts when the client input changes and ends with the client requesting service. And the last program starts when the services assembly returns and presses the client start button and ends with the client discussion updating to its current value. Any broken addresses in the application will show here. Let's review how the service and client work together. When one or more of the service requests gets filled in by a program, the client sends them to the service for processing by sending the whole services assembly. The service responds appropriately and sends back the services assembly with filled-in service request returns. Let's talk about the service-side programs assembly. There are times when a client needs a response that may require more than one request in sequence. Reserving something is a good example, where the client has a request that cannot be filled for one reason or another initially, but a satisfactory result is required before the service finishes. For example, I need a seat on that plane before I leave. This means that one or more service requests are programmed to respond to the service side. Anything that triggers on the service side has to be put in this assembly. Let's talk about services and security. In general, services represent a security risk because clients are sending you programs that are going to execute on your machine in your environment. This is the exact same problem we see with content like Flash, Adobe, etc., which are programs made by strangers that run on your machine in your browser, a serious risk in an environment that lets you write data to memory. The good news is that in AOS there is no such thing as write. No program can come in and overwrite any data in the AOS system. All data in AOS is self-managed and therefore cannot be written to. This leaves reading unauthorized data as the only possible security risk. To eliminate this problem, Services and Clients scan incoming services assemblies for addresses that are external to the assembly and deletes them if pointing to an external address. So here's the 7 security rules for Services and Clients. On the client side, external addresses are only allowed in request inputs and service request returns. On the service side, external addresses are only allowed in filled request inputs and service request returns. Request inputs that might get filled on the service side must not have addresses that are external to the service's assembly. They will be deleted for security reasons before the service processes any requests. Service request returns cannot be viewed or changed on the client side to hide details of the service machine from the client. The return address for a service cannot be changed manually. A service published assembly can only be saved manually on the service side and viewed for correctness in a client. Service-side programs are not allowed to trigger off of or access data external to the service's assembly.